This video provides an introduction to probability, which is the branch of mathematics that describes random behavior. When we talk about randomness or random phenomena, we're talking about situations where you can envision many repeated trials and the individual outcomes in the short run are unpredictable, but in the long run there's a pattern to these outcomes which is describable mathematically. Randomness shows up in lots of situations. Everybody's flipped coins or rolled dice or played cards, and randomness certainly shows up in situations like that. But it has many more. It shows up in many more situations besides games of chance. It's very important in the world of finance and economics. It's very important in the sciences, like biology and physics have random components to them. And it's the basis of all statistics. In statistics, randomness is actually an advantage. We use random assignment to treatment groups in an experiment. We use random sampling from a population to answer questions. And in these situations, randomness is actually an asset rather than a liability. In this video, we're going to talk about how what are the basic concepts of probability and how we describe randomness mathematically. We'll start off with the idea of a sample space. This is the set of all possible outcomes of a random phenomenon. For instance, if you flip one coin, the only outcomes possible are a heads and a tail. And so our sample space is just heads or tails. If we flip two coins, there are four possibilities. You could get two heads, a heads and a tails and a heads, or two tails. If you flip three coins, there are eight possible outcomes. Three heads, two heads and a tail, heads, tails, heads, etc. And they're listed on the screen. Now, if you want to figure out probabilities of outcomes, it's important to be able to count them. And a lot of counting relies on this fundamental counting principle, what we also call the multiplication principle. It basically says if one task can be done m ways and another task can be done n ways, then the two tasks together can be done in m times n ways. And you might see that above where we flipped one coin, that could come out two ways. If you flip two coins, each coin could come out two ways, and if you multiply 2 times 2, that's where you get the four outcomes. If you flip three coins, the first coin could come out two ways, the second could come out two ways, the third could come out two ways, and 2 times 2 times 2 is 8. And that's where the number of outcomes in those sample spaces comes from. If you look at dice, if you roll one die, there are 6 possible outcomes. 1, 2, 3, 4, 5, and 6. This is a regular 6-sided die. If you roll two dice, the first die could come out 6 ways, the second die could come out 6 ways, and so the total number of outcomes is 6 times 6, or 36. And that sample space can be written as 36 ordered pairs, where the first die's outcome comes first, and then the second die's outcome comes second. And here is that sample space. Okay, this is something you might want to get familiar with. This shows up a lot in probability exercises, so it's a good sample space to know. And it helps you if you're playing games that involve dice to know which outcomes are the most likely and which are least likely. And you can sort of tell what those might be by looking at the 36 ordered pairs on your screen. Now, if you flip 4 coins, each coin can turn up 2 ways. That means the number of outcomes in the sample space is 2 times 2 times 2 times 2, or 16. If you flip 5 coins, the number of outcomes is 32. And if you flip n coins, the number of outcomes is 2 to the n power. An event is a subset of the sample space. And it could be a single outcome, or it could be a collection of outcomes, but it's just some subset of the sample space. Now, the probability of an event is its long-run relative frequency. That is, how often, or what fraction of the time, or what percentage of the time that event would occur in many, many trials. In classical probability, the outcomes in the sample space are assumed to be equally likely, and the probability of an event in that case is just the number of outcomes in the event divided by the number of outcomes in the sample space. And so when you're doing classical probability problems, counting is going to be very important. You need to be able to count how many outcomes are in the event, count how many outcomes are in the sample space, and then divide. So counting is a big part of the process of finding probabilities in a classical situation. There is an example. If you flip two coins, we could let event A be that we get at least one head, and that could be two heads, a heads and a tail, or a tails and a heads. There are three outcomes in that event. There are four outcomes in the sample space, which you saw above. And so the probability of this event A happening is 3 divided by 4, 3/4, or 0.75 or 75%. Probabilities are written all three ways, as fractions, as decimals, and as percentages. Now you notice that all these things are fractional, and there's a good reason for that, which we'll get to in a few minutes. If you flip three coins, you could let event B be the event that you get two heads, and that could be you get two heads and a tail, a heads, tails, and heads, or a tails first and then two heads. There are three outcomes in that event. There are 8 outcomes in the sample space, so the probability of this event B is 3 over 8, or 0.375, or 37.5%. If you roll 2 dice, we could let event C be that the total on the 2 dice is equal to 8, and event C can happen in 5 ways. The sample space contains 36 outcomes. We already saw that. There are 5 ways to get a total of 8 on your dice. You could get a 2 and a 6, a 3 and a 5, a 4 and a 4, a 5 and a 3, a 6 and a 2. There are 5 of them. You can find that in the sample space that we showed a few minutes ago. And if you divide 5 by 36, you get the probability of C, this event. Now, an event has a probability of 0 if it never happens, and a probability of 1 if it always happens. And this gives rise to the 2 most basic rules of probability. 1. The probability of something in the sample space happening is 1. Some outcome in the sample space has to happen every time you conduct a trial. Every time you flip a coin, you have to get a heads or a tails. Okay, and so the probability of something in the sample space happening is 1. Some people say that's the something must happen rule. And then rule number 2 is that for any event A, the probability of A is between 0 and 1 inclusive. Now the probability of an event can't be less than 0, because if the probability is 0, that means it never happens, and nothing can happen less often than never. So probability cannot be less than 0. And the probability can't be greater than 1, because the highest it could be is 1, because if it happens with certainty, it happens all the time. That would be the maximum probability there. It can't happen more often than always. So probabilities cannot be less than 0. They cannot be greater than 1. They have to strictly be between 0 and 1 inclusive. And that's an important thing to remember. A lot of people forget that when they're calculating probabilities. They might get a negative number for their probability as a result of some calculation. That generally means that they made a mistake in their calculation rather than that they actually got a negative probability. That should not happen. And if similarly somebody were to calculate a probability that's greater than 1, that would also be impossible, and that would have to be the result of some mistake. So you can use that second rule as a way of checking your work for reasonableness as a first pass, and I want you to always keep that in mind.